Hello and welcome back to the channel. In today's video, we have an interesting project to work on together. This is as decided by the community, and you can look at how the community voted in the community tab. Now, before we continue, if this is your first time in the channel and you have not subscribed to the channel, don't forget to like and subscribe. Now, let's go back onto the project. Now, this project is going to be a real-time streaming project with Apache Spark. And let me give you a background use case for this. Now, we have a driver that is traveling from central London to Birmingham. Now, they want to have an IoT device that collects information about the vehicle, about the GPS location, the weather information, the medical info, any accident or something that happens on the road. All this information are being gathered by this IoT or any devices at all and being sent to our system. We want to analyze this data in real time and be able to work on this data in real time. And as the driver is moving on from London Central, the central London to Birmingham, we are collecting this information alongside. Now, if there's a delay on the road or something like that, we get all this information in real time. How do we handle all of this information? We're going to discuss that in detail in the architecture section. But that's the background overview of this project. Now, how we connect the bits and pieces of this system together will also be discussed in shortly. So let's go into the architecture section and discuss how that looks like. Here is the system architecture we are going to be building today. We are going to start by collecting information about the vehicle that is traveling from London to Birmingham. To put that into context, this is how the map looks like. So it's going to start from central London and move on from central London to all of these steps. It takes about 2 hours, 30 minutes, depending on the time. If you have an optimal without traffic and no issues and incidents on the road, it's about 2 hours, 30 minutes from central London to Birmingham. But interestingly, we are going to see how that applies to our case, where we're going to be visualizing traveler that is moving from central London to Birmingham in our case. We're going to be collecting the vehicle information that the driver is driving, then the GPS information of the car, so we get accurate information about how the car is moving from central London and which route it's taking through the latitude and the longitude information. Then we have a set camera information in here, which is going to be a screenshot. This is going to be a dummy because we don't have an IoT system that is live and listening to sending information from live cameras in this case. But this is going to be something that is possible if you have a live system that is collecting camera information and sending it to the system. It's also possible. Then weather information is something that we are going to be looking at as well. Then we have the emergency information. If there's maybe an accident on the road, the policeman stops you on the road, there's a fire, there's any other kind of emergency information that might disrupt the traveling from central London to Birmingham. This is what we're going to be looking at as well. We're going to be collecting information about that. And by the time the data is collected, and let's say the police arrest you by, let's say, 10 o'clock, and then you were released by 10:15 or 10:10, that also is going to be captured in our data set. Now, once that data comes in, it's going to be sitting in our Kafka system. But before we do that, we're going to set up our Apache Zookeeper, which is going to be the one controlling whatever information is going into Kafka, and the multiple Kafka information. If you have multiple brokers, like 2 or 3 brokers that we can control, Zookeeper is going to help us doing the coordination with that. So each of these data that is coming into the system is going to be passing through Kafka. And then we have a consumer, which Apache Spark, that is listening to events that are coming into Kafka. Once the data is being listened and consumed with Apache Spark, we're going to stream the data directly to AWS. In this case, we're going to be writing into S3 bucket. At the end of the day, while the data is getting written into our S3 bucket, by the time the traveler gets to Birmingham or before then, we can easily write our condition, which is going to be our process on AWS Glue, to extract information from our raw storage using the data catalog, of course. We write that into with AWS Glue. We automate the process to get that from the AWS catalog. Now, once the data gets into catalog, it makes it easy. We just have an access to connect to Amazon Athena or Redshift in this case. All of this is going to be controlled by AWS IAM, of course. We have our roles and securities in place, and then Amazon Redshift is going to be our final destination in this case for the data. Now, we can also visualize the same thing with Amazon Athena, but we're going to be focusing so much on Redshift. But we're going to have a bystander sitting on Amazon Athena where we can just write a query and visualize that. But the major thing is going to be done with Redshift. Eventually, we're going to be having Power BI visualizing Amazon Redshift if we have enough time, or we use Tableau or Looker Studio. That is the entire architecture of the system, and that's how the system is going to be looking like. So before we continue, if you have not subscribed to the channel, don't forget to like, comment, share, and subscribe to the channel. It is with these likes and comments and subscription that keeps motivating the channel to grow and to reach more people, as well as keeping the information fresh and up to date. So enough of that. Let's get into the coding section and start getting our bits and pieces all connected together. So see you in there. Now, make sure that you have your Docker desktop installed. If you don't have it, you have to go to docker.com and then get Docker installed on your machine, whether you are using Windows, Linux, or Ubuntu, or any others, maybe Mac OS. It doesn't really matter. What matters is you get Docker desktop or Docker engine installed on your machine, so you can easily get all of these things that we're doing and follow through along as we code. Now, once your Docker instance is set up, we are ready to get started with our architecture. We are going to come back to these producers that are sending data into this Kafka and then our Apache Spark much later. But for now, let's set up this architecture and then continue from there. Okay. Now, going back into our PyCharm, I'm going to be using PyCharm in this video. So if you are interested, you can also use PyCharm or you can use any other IDE that you like. The process is pretty much the same. I just like the UI and the layout of PyCharm. There's nothing special about it really. So you can use any IDE. So just click create a directory and then you get a virtual environment and you should be good. So in this case, I'll be calling this project Smart City. Now I need a main py, which is what we're going to be working with basically, and I'm going to change my Python version to 3.9. So for some of you that might miss this part, the Python version that is being used in this video is Python 3.96, but you can use 10 as well, and I think 11, but it is very dicey to use the latest version, which is 3.12 as of the time of this recording. So I would say if you're using 3.12, you proceed with caution. All right, let's proceed. It will be good to have your Docker desktop installed and up and running before you continue. So if you don't do that and you are trying to run the commands that are going to be run in a few minutes, then you are going to have run into some issues. Okay, so let's continue. Now, it is possible that by the time the system gets up, you want to be sure that your virtual environment is sitting in the right place. So easily, if you are using Linux systems or Mac OS or whatever, you can do with Python. It's easy for you to get where the data is sitting. Now, in my case, it's sitting in the .venv, which is exactly where I want it to be. So now let's continue. So let's get to the architecture of the system. Like I said, the architecture of the system we are currently working with is the Zookeeper with Kafka, then with Apache Spark, all sitting on Docker. Okay. So let's get our Docker Compose in. Okay. I'll be using Docker Compose or YAML to facilitate the services installation. All right. So let's get that in. All right. So let's start. So we have a version. In this case, the version we're going to be working with is version 3. Then we have our services. The services we're working with is the Zookeeper. All right, Zookeeper, as well as Apache Spark. But before we get into Apache Spark, let's fix Zookeeper and the broker first. So we have our image. The image that I'm going to be using is going to be the image from Confluent Inc. I like the image, so you can use any other Zookeeper that you like, but I'll be using CP Zookeeper in my case, and the version that I'll be using is 7.4.0. I find it to be safe, so you can use the latest version. I think there's an update to that, but if you like, just keep it as 7.4.0 and you should be good. The host name in this case is going to be Zookeeper. Excuse me. The container name is going to be Zookeeper as well. Zookeeper. Then the ports that I'm going to be exposing in this case is 2181. I'll just use the double quotes 2181. 2181. So that's the internal and external IP at the ports. Then the environment that I'm going to be working in, the environmental variables. So we have the Zookeeper client port, which is 2181. All right. Then Zookeeper tick time is going to be 2000. Then the else check in this case, I'll have a test so that each time we are doing an else check, because of the dependency, we want to be sure that this Zookeeper is ready to accept connection before continuing. So I'm going to have a command. The command is going to be a bash, which is going to be the bash command, which is bash C. And what that is going to do basically is to say echo, are you okay? So are you okay? So once this returns, are you okay? And in the local host, I should be good. All right. Local host 2181. So what that means is it's going to be running, are you okay in the terminal? Once that is done, and once I receive a response, then probably it means that the server is ready to accept connection. The interval in this case of the test is going to be 10 seconds, and the timeout is going to be maximum of 5 seconds. The number of retries before it fails is 5. So if the Zookeeper doesn't respond after 5 tries, just terminate the process itself. So I'll call this data mastery lab as my network. So let's get in our network. So the network in this case is going to be data mastery lab. All right, so continuing, hopefully this gets us up and running and we should be good. Okay, now our Zookeeper has been set up, so we've ticked this off our box. Now let's continue with Kafka, which is the one that is going to be controlled by Zookeeper, and the coordination will be done by Zookeeper as well. So let's continue. Now we have Zookeeper. Then the next thing will be to get in our broker. The broker is going to be our Kafka, of course. Image. The image is also going to be coming from Confluent Inc. Like I said, you don't have to use the same thing, so you can use a different Zookeeper or Kafka broker, which is totally fine. So far you expose the same properties or similar properties, you should be good. The container name in this case as well is going to be broker. It's going to be depending on the Zookeeper in our case, and on what condition is the dependency is going to be. So the service LD condition, what that means is until this test returns an healthy condition, this broker is not going to get started. It's just going to be keep pending. If it fails after 5 retries, this is not going to get created. That's what the dependency means really in short term. And then once the condition is there, we have our ports, and we're going to have the port is going to be 9092 for the internal and external IP, external port, 9101 as well for the, I think this is the JMX stuff. Now we have a lot of environment in this case. I'll just copy that because it's a lot. I don't want to make mistakes, and then we keep debugging that before getting into the actual activity. All right, I'll just paste that into the environment section in here, but I'll just quickly go through them so we can explain what each of them do and how they function in real sense. So the Kafka broker in this case, we're using one broker. So the broker ID is broker 1, and it's going to be depending and connecting to Zookeeper on Zookeeper 2181. The listener security protocol map is plain text, and we're using plain text in this case, and plain text is also going to be plain text. The advertised listener is going to be broker 2902, which is where it's going to be accepting connection from, or as well as 9092. All right, so these are the two things that is going to be we can use to communicate with our broker. The metric reporter is this for the Confluent metric reporter. I think this is majorly Confluent related. So if you're using any other broker information as your server, as your broker, you may not need to set the Kafka metric reporter. We also have the Kafka offset topic replication factor is 1. You can increase this if you have multiple replications. You want to increase the number of replications, but the rest are just they're just more like Confluent information. In this case, we have the transaction state as well. Then the JMX port is 9101. The JMX host name as well is localhost. Schema registry, in this case, we're not using it, so it's really useless. So you can remove this, but I'll just leave it as it is, but it doesn't really hurt if it's there. Now for the rest is this is Confluent specific. If you're using Confluent, you should add this as well. This is the metrics reporter bootstrap server and the topic replica and the metrics enable. We're not enabling any metrics, and even if any metrics is going to be going out from broker, is going to be anonymous. Okay, now let's put this on a network. The network this is going to be sitting on is going to be networks. It's going to be data mastery lab. Good. All right, so continuing, I'll just get this here, data mastery lab. Good. Now continuing, we need to get the health check as well. So the health check for our broker is similar to what we have before. In this case, this guy, I can just copy this and just modify the command really. Just maybe delete this, press enter here and paste that in there. So this is going to be a bash command as well. But instead of are you okay, well, I'm going to be using the nc, and this is going to be ncz localhost port 9092. So what this is just like doing is more like doing like a ping of this 9092 to see if it is ready to accept connection. I'll leave the interval and timeout and the retries as well as the same. Now what this means basically is that our Zookeeper and our broker is ready, and we can spin them up while we continue with our Apache Spark installation. So let's see if everything is working fine before we continue. To do that, we do docker compose up and in detach mode. Now, because we're not building anything, so if you have a Docker file and you're building an image for that, you will probably need to get in your Docker flag for build. Otherwise, the build is not going to reflect. Okay. But in this case, we're just using the normal system. We're not building anything. So it's easy for us to just Docker compose up in this case. All right. So if you look at this, we are creating the smart city network. Zookeeper is created and our broker is started. So if you look at our dashboard, smart city in this case is coming up. I don't want to click on that. I just want to click on this down, and you can see we have our broker up and running and Zookeeper as well up and running. So let's continue with our Apache Spark setup. Okay, so we need to get in our Spark master worker architecture. So to do that, we are going to have our Spark master. Now, because the Spark master, they are kind of related in some ways. The only difference is everything is the same system really, but you have the class that is differentiating them as master and worker. Module, the properties are really the same. So what we're going to do is we're going to have a small module that we can replicate across the master as well as the worker as well. But we just specify where the master is going to be. We have a class for that, and for the workers as well that are going to be working for the master in this case is going to be inheriting the same thing from this small module. All right, so let's quickly do that. So in our master, we're going to have image. The image is going to be Bitnami Spark, the latest. That's the latest version. Doesn't really matter what it is. So we are going to have our volumes. The volumes is going to be getting information from which we don't have jobs right now, but we're going to have a job, which is where we're going to be putting all our Spark jobs. And we're going to be mapping this folder in our local system to OPT Bitnami Spark jobs. All right. Now, the command that I was talking about that is differentiating the master from the worker is going to be coming from Bitnami bin, the Spark class. It's going to be org.apache.spark.deploy.master.master. All right. Now, finally, the master is set up. We just need to expose the port. So let's expose the port for the master. So in our case, we're exposing 9090. All right. So let's say 9090 as our local, and then in the container is 8080. All right. So internal and external. So we have 7077 as well, because this is where our Spark URL is going to be sitting on. So it's important we expose that as well. Finally, we get in our networks. The networks that this is going to be working on is Data Mastery Lab. Simple as that. Good. Now, as Data Mastery Lab. Good. Now, the next thing is to get in. What am I doing? Okay, that is fine. Now, the next thing is to get in our workers. Our master is fine. So to do that, let's get in a small module so we don't keep replicating the same thing over and over again. So we have Spark common in this case. This is a name that I choose by myself. You can choose any name so far it's maybe relatable and you can easily relate to that. So the variable for this, when we want to reference this, is going to be Spark common. All right, so the image for this small module is going to be the same thing as our master, Bitnami Spark latest. All right, and the volume we are mounting for each of the workers is going to be the volumes, is going to be jobs, the same way we have it for. In fact, I will just quickly copy that, the volumes command and the ports. I'll just maybe just copy this guy. All right, and then in the volumes, replace that. This is fine. Now for the workers, this is going to be the workers. So it's going to be different from master. It's not going to be master in this case. It's going to be being Spark class, Spark deploy worker in this case, and the worker. Then we have to pass in our Spark URL. The Spark URL is going to be Spark master in the port of 7077. All right. So this is where our Spark master is sitting in, and we're passing this. So this knows that this is where the master is sitting in, and whenever you want to receive information, you are receiving it from there. Then the final thing is the depends on. Of course, the worker is going to be depending on the master, of course. So Spark master. All right. Now let's set in the environment that each of the workers are going to be inheriting. So we have the environment, we have the Spark mode. The Spark mode is going to be worker. All right. The Spark worker core nodes, which is the number of cores, for each of the worker. So if you have enough compute, you can increase these cores. That will mean that your system will be way faster, and each of the workers will be more efficient. But 2 is also fine. You can have as many workers as possible. All right. So memory is going to be 1 gig. Now, interestingly, if you reduce this from 1 gig, your worker may not work. So I will recommend a minimum of 1 gig. So you can try that out and see how that looks like and give me a feedback in the comment section. So I'll just copy this Spark master URL as my Spark master URL. Finally, we get in the networks, and that's all we need to do. Networks. Okay. The networks in this case is going to be Data Mastery Lab. Good. Finally, we have a variable that we can use now. So let's get in our workers. So I'll just get in the first 2 workers, and you can do that. You can increase the number of workers if you want. So I'll have Spark worker 1. In this case, it's going to be inheriting from asterisk Spark common. All right, simple as that. For our second worker, we do the same thing but change the name of the worker. So if you want to have more than 2 workers, you can actually double copy that and then paste that and just change the name 3 and 4. All right, so what I'm going to be doing, I'm going to start with this 4, but I know this is going to give me some compute issues, so I'll just comment this out for now. All right, so let's use these 2 and see how the system performs under stress. Let's stress this out. All right, Docker compose up the dash and takes that for a spin. You can see that we have our Spark master created and the Spark worker 2 and the worker 1 as well created, which is what we have in here, which is good. So interestingly, if you go into the local host 7077, you should see something like this. We just wait a little while for the master to be ready. I think it's still currently running. What's this? Exception in connection. So I think it's still currently waiting. Something is too large in this case. I think I'll just wait for this to finish the initialization. I think it's still starting up. Starting up. So we just wait a few more minutes for that to be done. And while this is ongoing, we just go along with our coding. We come back to this much later to test if our Spark master and worker architecture is up and running before while we continue. All right. Now, interestingly, even though we didn't create our jobs directory, by the time we spin up our Spark worker, because we map it to our jobs directory, it created the job directory for us. And that's one thing you have to be careful about. If you map it to a file and you didn't create the file before running, it's going to create a folder for that particular file. But in our case, folder works just fine. All right, so let's get in our main.py into jobs. That's where we need it anyways. So, and then we do another touch, jobs, and inside our jobs, we're going to create a new file, which is going to be our Spark. I'll call it Spark City really, .py. So these two files are what we're going to be working with extensively. So the main.py is where we're going to be doing the production, and the Spark City is where we're going to be writing our Spark jobs to listen to events from Kafka. Now, for our main.py, we are going to start by installing a few packages, which is what we're going to be using. So we do pip install. We're going to be installing Confluent Kafka, Simple JSON, and PySpark. So the PySpark version that we're using in this case is the latest version, of course, Simple JSON Confluent Kafka. So I'll just run this to get those packages installed and saved into my requirement.txt. So if I do pip freeze requirement.txt, what it's going to do is populate the requirement.txt with this package. So by the time we install a new package, we need to add requirement.txt as well as part of the, so we can export it to requirement.txt. So for those of you that don't know how requirement.txt gets created, you do pip freeze, then greater than symbol requirement.txt. So let's continue. So I'm going to be importing OS, of course, importing Confluent Kafka. From here, so from Confluent Kafka, import serializing producer, because we need to produce a record, even though we are not doing that right now. So we import simple JSON as a JSON as well. And finally, we import PySpark, which is, we don't need it right now. So let's leave that for now. So let's get in the latitude and longitude for Birmingham and London. So London coordinates, in this case, coordinates, it's going to be latitude. Of course, this is a JSON. It's going to be latitude. Of course, the latitude is the 515. This is something that I checked and looked up on the map, so I don't know it offhand. Then we have the, what am I doing? Yeah, good. So we have the latitude, then we have the longitude, of course. So minus 0.1278. 0.1278. Okay, good. Now that's for London. So let's put this on the same line to save some space. And yep, we do the same for Birmingham as well. All right. All right. The latitude for Birmingham, you can look it up on Google, of course, 524862. All right. Then for the longitude is minus 18904. So the logic we are applying to this is by the time I'm going to just apply a simplistic value. In real sense, you want to get the actual figure that is going to be more sophisticated and is going to be a representation of actual data, right? So in our case, we're going to have latitude increment, which is what we are increasing, and of course the longitude increment as well. So we have the Birmingham, because from the bottom, that's the south, is going northeast. Okay, so we have the latitude from here, latitude. All right, we're going to subtract that from the London coordinate, which is going to be the latitude as well, latitude. And while that is ongoing, we divide this by 100. We do the same thing for the longitude as well, which is going to be longitude, and Birmingham coordinates are just longitude. I'll just copy that and replace that with a skid. And that's how we need to do the incremental for both latitude and the increment for both latitude and longitude. All right. So that's the process for that. Now let's get in our environment variable. So let me just comment this out and say this is going to be what we're doing basically is calculate the movement increment. So this is where we are doing the calculating in the movement. Okay. All right. So in real sense, you have to, put the actual value there or get the actual value. So the environment variables, of course, that we're going to be using for configuration is going to be coming in from either the OS or by default. So we say Kafka bootstrap servers. It's going to be, you can get that from the os.get-env. So if that is set up in the environment, all well and good. If not, we can just default it to our bootstrap server. Okay, bootstrap servers is going to be localhost 1992. Then we get the vehicle topic, which is where we are catering for this. Any information that is coming about the vehicle is going to be going into vehicle topic, GPS topic, camera topic, weather topic, emergency topic, of course. So vehicle topic is going to be os.get-env, and that will be vehicle topic. If that doesn't exist, use vehicle data. Then for the GPS, use the GPS topic, get-env GPS topic. Then we have GPS data. For the traffic as well, traffic information, traffic topic. This is just majorly traffic information, whether there's traffic on the road, we get that as well, or you get the driver gets hold by the traffic. All right, that will be going in there. It's an anomaly, really. Traffic data. Then we have the weather. So if it is raining, as always in London, so we get information about the weather as well, weather topic. Then we have weather topic, weather data. Finally, we get the emergency, which is the emergency topic. So os.get-env, and that will be emergency topic. If that doesn't exist as well, get that into emergency data. Lovely. Now, once this is done, the next thing is to now get in the actual logic. I'll just minimize this for now and get started with that. So we have our start time, which is the time that is going to be the traveler is going to be starting the driver. All right, so I'll just stick that to the current time, which is the date time.now. Then the start location is going to be the London coordinates. We just copy that, simple as that. So let's import our date time. It looks like we don't have it, so in our here we just say import, in fact from date time, import date time. Okay, so going back here, we have our start location and the time we start. So let's get in our different function that is going to be used. So let's start with the entry point. So if the name is going to be main, if the name is main, so we can start running from there. So let's get in our producer config, which is our Kafka information, our broker information. producer config. It's going to be for this is how you configure Confluent Kafka, by the way. So you have bootstrap servers, bootstrap.servers, really. Then you have the Kafka bootstrap server that we already created. Then if there's any error, and that will be our error callback, we just do a lambda function, a lambda to print that. The error for lambda is going to be just print Kafka error, and the error is simply error. So if you have your Kafka maybe hosted somewhere else, and you have, most times if you are something like a Kafka Confluent environment on the cloud, Confluent Cloud, if you created your producer, which is your broker in there, you have username and password. So you need to get in your SASL information, which is the username and password for that. And if you have a schema registry as well, because Confluent Cloud uses schema registry, so use the schema registry in that case, the username and password, as well as the host information for the schema registry. You put that in the producer config. Most times you want to put that inside a different configuration file that you can maybe exclude from committing that from your GitHub or something like that. So that's just a different case entirely, but let's stick to this, our use case in this case, all right? So going back to our code, we have our producer config set up properly. Then we have our producer in this case. We brought in our serializing producer, if you can still recall from Confluent Kafka. So we use the producer config to tag into our serializing producer as a parameter. All right. So let's try and catch. If there's any error, we simulate the journey. So let's simulate journey, which is going to be used with the producer, and the vehicle we're going to be using is called vehicle code with you, CWY, and then maybe 1 2 3. All right, interesting topic, vehicle name. All right, so if there's an error, we call that except. So if you stop the journey yourself, you say that's through a keyboard interrupt, maybe Control C or something like that. Simulation ended by the user. Otherwise, except we have exception as E. Any other error, just say an unexpected error occurred. If I can only type occurred, I think it's double R, isn't it? Yeah, it is. All right, so let's put E into that and we should be good. So let's create our first function called simulate journey. So this simulate journey is where we're going to be having all information about the vehicle information, and at the end of the day, we're going to be producing data from there. All right, so we have a simulate journey. All right, so we're getting the producer as well as the device ID, which is the vehicle information, really, device ID. So you can change the variable name if you like. So while this is true, what is true in real sense? What the true in this case is the value, the driver is still driving from London Central, the central London, to Birmingham. All right. So in our case, we get in our vehicle data, which is going to be generate vehicle data. How do we do that? We use that with the device ID, which is our device, the vehicle information. So let's create this function because we don't have it right now. So we have generate vehicle data, and then we get in because we are just passing the device ID to that. So it's easy for us to say we are creating a function that just passing device ID into that. Okay, simple as that. Here we get in a location, which we don't have right now. So let's get our simulated location. So we say simulate vehicle movement. So what this means is the very first time the driver starts moving towards northeast from the south. What that means is each location is going to be increased or decreased in whatever case, heading towards Birmingham in our case. So that's what that means when we are doing a simulation. So each time we get an information about our latitude and longitude of the driver. If there's any hold up or something like that on the road, then we get the same latitude and longitude on the space in the same space for quite some time, and we can build up our reports based on that to know what time the hold up happens and stuff like that. So let's continue. So the simulate vehicle movement, what we want to do basically is to get the information about the vehicle, which is going to be the latitude and longitude, of course. So we have def simulate vehicle movement. So let's declare this as global, the start location, and then we start moving towards Birmingham. All right, move towards Birmingham. All right, so start location in this case is going to be what is it? Latitude. All right, then we keep increasing the latitude by the latitude increment. Then for the longitude, we keep increasing the longitude as well. So each time the latitude and longitude gets increased. So we just add some randomness in this case. Let's add some randomness to simulate actual road travel. All right. So it doesn't mean we are just increasing by 2 or 3 every time or something like that. All right. So I just copy this again. Then the random is going to be coming from random. We don't have random imported, so import random. So random dot uniform. So we want the value to be uniform between minus 0.0005 and 0.0005. The same thing for the longitude as well. Okay, so it doesn't spike up. It doesn't go too far above 0.005. Okay, so eventually we just return the start location. I hope you are following me with this kind of picture that I'm trying to paint to you. As we are moving on, we're just increasing the latitude and the longitude by the latitude increment, which was the one that we subtract from the longitude from Birmingham to London Central. Then we divide that by 100. We just increase that by the time we are moving on, and the randomness we are adding is just 0.005. It's not too big, so we don't have a spike in the by the time we are moving on. All right, so that's what we're doing here in the simulate vehicle movement basically. And once we have our location now, the next thing is just to return an object that represents our location. So the object is going to be a simple ID, which is going to be UUID, okay, dot version 4. So let's import, okay, automatically imported. So we have our device ID. In our case, it's going to be the device ID. So let's get in the timestamp as well. Timestamp, which is the current time at that point in time. So let's get the next time because we want to keep increasing the time as well. So we want to keep increasing the time and getting the ISO format for that. So how do we do that? Let's implement this. Okay. So I'll just copy that, and above, what is it? Above the simulate vehicle movement, I'll just create a new word. I'll just copy this and paste that in there. So let's implement this function. It's going to be global, and the start time. All right. So the start time is going to be increasing because this is the time we are using to, keep track of how long it's taking the driver to get to Birmingham. Time delta in this case. Let's import that. Import that from date time, of course. So we just add our seconds. The seconds is going to be rand8 between 30 to 60. Basically, what we're just doing is just the simulation of update frequency. Really, it doesn't mean so much. It's just the update frequency for the time. All right. Then we just return the start time. Okay. Start time. Okay. So going back to our simulate journey, where is it? Here. We get the ISO format of that particular time because that's what we're returning in this case. Okay. Then we go forward from here. Once we have the time, I just add a comma to that. Then we have the location, the current location of the driver, which is the location latitude, of course, and at the end of the day, because we are using a tuple, all right? So location for the longitude as well, longitude. So this will be encapsulated or enclosed in a tuple, all right? So we have the speed of travel, which is going to be random.uniform, all right? 1040. So you shouldn't be too slow or too fast. So if you are in central London, the maximum speed is about 20. So once you get out of central London and you are heading up on the highway, maybe M1, I think you can do up to 40 or more. Okay. So the direction that we're going, basically, I'll just, put this as by default northeast. All right. From our central London. Of course, it's northeast. So what car information are we getting? Most times, all this information will be sent in from our IoT device. Okay. So the maker of the car is Toyota. I think I prefer BMW really. I don't want to use Toyota. Let's use BMW, all right, or Porsche or whatever. So let's say BMW C class, maybe C500, if that car exists. Then the year is 2024. What's the latest model? All right, the full type. If there's any information about that, I'll say I'll just call this hybrid, really hybrid. Okay, good. So that's enough about our car. We can get all that information from our IoT device that is sending information to us. But for now, let's just leave it at that. If there is any other information you can add to that, it's totally fine. So I'll just leave it at that. So once we get our vehicle data in this case, it's easy for us to say, let's print that and see how that looks like before we continue. So we know whether there's any error that we need to fix and or something like that. So print vehicle data and just break. I just need a single record. Okay, so let's run this in our terminal. I'll just come to the terminal and then Python jobs and main.py. So let's see if we are able to get that. We get the ID, UUID, device ID. Okay, the timestamp is this, the location is this, the speed, direction, make, model, year, full type. Good. So that means everything up to this point is still very good. So that's a good sign. So let's continue. The next thing is to handle, we've handled the vehicle information. Let's handle the GPS information as well. So GPS data, all right, GPS data. And that will be collected from generate GPS data. All right. So what we need to do that is to get the device ID, which is the car, of course, that we're getting information for. And then we get the timestamp because we don't want the timestamp to be too wide apart. So we want to get the timestamp. So each time we're getting information about the car, we're getting all of this information at the same time. So there could be a delay, which is fine. But if not, it shouldn't be too wide apart. So we just say maybe every 1 minute delay, really. So we handle that in our Spark video, Spark session. All right, let's continue. So our GPS data in here, we are using the device ID and the timestamp. So let's implement this guy. All right. So coming back to the generate GPS information in here, we just create, yeah, I think I just click on one usage in there. So I'll just copy that. And then we get in the device ID. All right, the timestamp. And of course, our vehicle is private. So the vehicle type is going to be private. Okay, so we're not using a public car, of course. Bus takes a longer time. Okay, so you have UUID in our UUID.version 4. Then we get the device ID. Okay, as simple as that. Device ID, you get the timestamp. Okay, and then that'll be the timestamp coming from our input, our parameter really. And then speed is going to be random. Of course, we don't need this to be too wide apart as well. It should be uniform between 0 to 45, maybe to 40 for the GPS. Yeah, that's fine. So of course, this is going to be in kilometer per hour. So shouldn't be too wide apart. So comma. Then the direction is going to be, of course, east. Maybe northeast, really. Yes, let me just leave it as northeast, really, because that's where we're heading to anyways. So the vehicle type, I'm trying so much to make this look something like a real-time scenario, how you can get all the information you can get, really. Okay, so that's our generate GPS data. And if you go back down, we have our GPS data in here. So the next thing for us to do is generate our traffic camera information. So we have our vehicle data, we have GPS data. Let's generate our traffic information as well. So we come in here, I'll say dev generate traffic camera data. All right, so we need the device ID, the timestamp, of course, which is the current time, and the camera ID that we are using to because there might be multiple cameras, so it might be that we are getting information from multiple cameras. So in our case, we just stick to one camera, but we can extend this and make it a little bit more sophisticated by adding more cameras, more vehicles, and we can get more information from our system. Okay, so UUID version 4, then we have the device ID, which is going to be coming from device ID, the camera ID is going to be from here. That's the camera that is sending this information to us. Then we have the timestamp. This is happening. Okay, timestamp, and this is usually happening at a particular time. Then we have a snapshot. This is where it gets tricky. All right. Interestingly, I couldn't find any URL that can give us the actual camera footage that we can use. But what we can do is getting our base64 encoded in here, encoded string. So in a case where you have actual snapshot or actual screenshot of what is happening, what you want to do is maybe it's a URL, or you want to save it as a base64, you can easily just use request.get to do that and encode it in base64, or you use the actual URL, maybe saving to S3 bucket, you just get the actual S3 bucket URL and stamp it into this place. So that solves the problem for us. So because we don't need any picture really, we just get the snapshot information like that. So let's get the traffic information into our journey as well. We have the traffic, that will be traffic data, isn't it? Traffic data. I think traffic camera data sounds better, really, from a particular camera. Okay, so we have our device ID, we have the vehicle timestamp, vehicle data, and that will be the timestamp. And the camera that is sending us this information, we can give it any name. So let's say camera 123. Maybe I'll say Nikon. I don't know. Nikon camera, Nikon cam 123. All right. So that's the name of the camera. It could be anything really. So I just that's what comes to mind. All right. So let's get into the weather data as well. So right now we fixed this vehicle data, GPS. Vehicle data is taken care of, GPS is taken care of, camera has just been taken care of. We are left with weather and emergency. Okay. Okay, weather data is going to be generate weather data. And in our case, we're getting the device ID, the vehicle data, and extract the timestamp from that, because we want that timestamp to be unique across, okay? To be the same thing for all of the data. Vehicle data, even if the data comes in late, it's okay, but we get the same data across board, all right? So let's create a function to do this, okay? So we can just scroll up to the top. Where is it? Up to the top. Yeah, in here, and just getting dev. We have GPS traffic cam. Okay, I can get it in here. So dev. So I just wanted to look at sequential device ID, timestamp, and the location. So we just return, just like we returned before. I'll just get in UUID, device ID, and the location, maybe location. I think we should probably add location to the camera information. So we have the latitude and the longitude of the camera at what time is getting information to us. So we have the location in here, and that will be location. So let's quickly fix that before we forget. So our traffic ham is getting location for us. So I'll just get this in and get in the location. Okay, and we should be good. Good. So let's get back to our weather. So location in this case is going to be the location that the data is coming in. Timestamp is going to be, of course, timestamp. Then let's get all this weather information about the area, all right, that the car is currently in. We have the temperature. With the temperature shouldn't be that high. So usually we have a uniform temperature from minus I'll say -5 to a maximum. The maximum we've experienced in London to Birmingham, maybe let's say 26 maximum. All right, it could be more, but I'll just stick to 26 really. So let's say weather condition. Temperature, not temperature. Okay, you probably saw that. So we have the random.choice for the weather condition. Okay, random.choice, and we have the sunny, if it is cloudy, if it is raining, or is snowing. I think we should probably add a seed to our random, so we stick to that random.seed. So let's say 42 as our seed. All right, so once you choose sunny, it's always sunny across board, so it doesn't change really, unless maybe you get to somewhere like Birmingham and it's maybe sunny there and snowing in London in summer. Precipitation, all right, so if there's any drizzling or something like that, okay, or any precipitation across board, we have 0 to maybe 25. I don't know. The wind speed most times is usually windy, so let's get the wind speed as well. Random.uniform. In real sense, you want to get all of this from maybe a weather API. I don't want to make things too complicated. That's why I didn't use the weather API really. Humidity is going to be random integer from 0 to 100, so it's okay. The humidity is this is of course a percentage, all right, so just in case you're wondering. Then we have the AQI, which is our air quality index. AQI. That will be for, of course, I want it to be okay. I think it should be uniform. Let's make it uniform across board, unless the AQI is in central London. It's a little bit bad. I wouldn't say bad, maybe not too, but when you move on the road, the AQI gets better. So I'll just say the AQI value goes here. Okay, so whatever AQI value you want to use, you can just tweak this to get your taste and to suit you best. Okay, so finally we get our weather data, which is weather data in this case. Now let's see what else we need to do before we continue, and that would be let's see, I'll just go down. I think I should just scroll this down a little bit here. Just minimize this. We have weather data. Finally, we just get our emergency incident data. All right, so that will give us access to generate emergency incident data. All right, so we just pass in an ID, maybe the UUID, which we don't need really. We can just use that. Vehicle data, get the timestamp, and that will be the device ID as well. Device ID, timestamp, and the location that the emergency happened. All right, just like before. Just copy this, okay, and then we paste that in. So let's create a function that helps us do that. Here we have weather data, and then we should get in our emergency function. Okay, the function here. Then we have our incident ID. I'll say device ID, really. Device ID. The timestamp. I think this should be underscore, so we keep it uniform across board. Timestamp and the location. Okay. You just return a JSON object. The ID is going to be, of course, in string uuid dot uuid version 4. Then the incident ID. Let's get in the device ID first. Device ID is going to be the device ID. Then for the incident ID. So that will be a UUID. I want it to be unique across board, so I'll use a UUID for that as well. Then we have the type. In our case, the type of incident is going to be a random choice, and that will be, maybe we shouldn't have used that random C, because once it selects fire, for instance, it's going to be fire across board. But I think you get the logic, really. So it doesn't matter what it is. So far there's an incident, and if there's none, it's okay. We're good to go. There's no incident. Okay. So timestamp, it will be the timestamp from our parameter. Good. Then the location is going to be location as well. Location. Then the status is going to be random.choice, and that will be between active or result. Okay, what that means is if there's a police incident, if it is still active, and how long it is active, depending on how long the number of records that returns the active and the time it takes between the start of the active to the end. All right, that will give us the result. So that will give us information about that. And if there's any description, of course, description will come in here. Most times you may not have this, but I'll just say if you have a description of the incident, you can put it in here. Description. All right. Okay, finally, we are good to go. So our emergency incident data, GPS traffic information, all of this has been taken care of now. So now let's fire this up into Kafka and see how that looks. But before we do that, let's test this data to see if everything is working fine before we continue. All right. So let's just print them. We say print vehicle data, print GPS data, print traffic camera data, and then print weather data. Finally, print emergency incident data. Good. So let's see how that looks like in the terminal. I'll clear this up and then run that again to see how that looks. Is there any error? Maybe not. There is none. So let's see what we have. We have the ID in here for the first one. I think we checked this out. It was pretty much fine. Let's double check this as well. Code with you. Timestamp is the same across board. The speed, direction, vehicle type is okay. Then we have this as well. base64 encoded string for our snapshot. I think everything is good, and we can start writing this to our Kafka. All right, let's do that. All right, we are leading to the end of this section. So let's quickly get in our producer, and then we produce this data that we're writing into Kafka. So let's do that. So the easiest way to do that is to create a function that we can reuse for that. So we can have produce data to Kafka. You can have the producer and then get in our vehicle topic and vehicle data, of course. Then we can replicate this a couple of times, about 5 times. Then we have the same done for GPS, done for traffic. We do the same for weather. We do the same for emergency topic. So we get this GPS traffic, we get in the weather, and then we get in the emergency. Okay, good. Now let's get this function that helps that handles all of this for us, because right now nothing is being created, to be frank with you. And in our simulation here, just above this guy, we can have our definition, and that will be produce data. We have the producer, we have the topic, and the data we are producing. So producer.produce, that's the syntax for that. So we just get in the topic. The key that we're going to be using for the production is a UUID. So let's convert that to string. Otherwise, we're going to get a challenge in that case. And the value is going to be deserialized, okay? To be serialized, that will be JSON.dumps. So let's serialize that. And we're serializing the data. But if there's any issue, this is where we need to handle an edge case. The edge case is in a case where we have the UUID not being passed correctly. This is something that can cause a challenge really by the time you are running your system. So it is possible you have that error. So if you don't handle this edge case, you might run into unable to produce data into Kafka. So to do that, let's quickly change our data. In this case, what? So in this case, let's just have our default serializer, just in case there's any challenge, fall back to this serializer. And I'm going to just say, this is a JSON serializer, and I'm going to encode this into a UTF-8 format. And finally, on delivery, I get in a delivery report, just to be sure that the data gets the delivery report. So just to be sure the data gets delivered to Kafka. So let's get in these two functions. All right, the very first one is the JSON serializer. We deserialize it. We serialize any object. So if the object is instance, okay. If the object is a UUID, so we just get say UUID dot UUID. So if it is a type of UUID, we just do a return for that particular object. That's a string. Simple as that. All we just have to do is handle this case. All right. So otherwise, we're just going to raise an error, a type error that we don't know this error. Okay. Raise. The type error we are raising in this case is object of type something is unable to object dot class dot name dot name, of course, is not JSON serializable. Okay. Yeah, that's a mouthful. Okay, so the final thing we need to do is the delivery report. So the delivery report is where by the time data gets sent to Kafka, we get the delivery report that has been sent. So if there's an error, if not, we get a message. Okay, so if error is not known, that means there's an error while sending. So we say message delivery failed. And the reason for that is simply because of this error. Else, we just print message delivered. Okay, simple as that. Message delivered to a particular topic, and we usually the topic comes in with the data really. So message.topic gives us actually the message, and we can actually get the partition that it was delivered to. By default, I think is 0. So if you have multiple partitions for your topic, you should be good. It should be easily and fairly straightforward to distribute that, usually in round robin, but it should be good afterwards. So let's see. The delivery report is done. We have message delivered to this topic and the partition. So let's run this and see if we just do once. We do one data, to produce one data first and see if the data gets loaded to Kafka. So we do Python jobs.main, and Nothing is showing here in the terminal. Is that it? So let's see if we have data in the Kafka topic. I'll just go into the exec tab and then we do Kafka topics. If the data gets sent to Kafka, the topics will be created. So we have bootstrap server. It's going to be broker 2902 or 9092. So let's see if we're able to list all of the topics. So it is still not sent at this time. So let's see why that is the case. All right. So going back to our code, we have our producer in here and we're breaking. All right. So let's see why that is the case. So let's handle one edge case in this case. So because we haven't handled that, if the car or the vehicle gets to Birmingham, what happens? We need to stop the loop. So if the vehicle data reports for the location, which is the latitude in this case, is greater than or equals to Birmingham coordinate for the latitude, that means it's about to go past latitude of Birmingham, and the vehicle and vehicle data location for the longitude, all right, is less than or equals to Birmingham coordinates for the longitude. Okay, that means the vehicle has reached Birmingham. So we can just easily say print vehicle has reached Birmingham. And let's end our simulation. Simulation ending. And easily we just do break. And that's the condition. So once the latitude is greater than latitude of Birmingham and the longitude is less than or equals to that, then of course it's because it's northeast, so the latitude will make more sense to be greater in that case. All right. So finally, let's say we don't need this break. Let's just give it some time to sleep and then to produce. So let's say every second. I'm going to increase this a little bit, but for now, let's leave it at every second. So I'll say 5 seconds. We can reduce this much later, but let's leave it at that. Okay, so finally, let's run this. Once we produce data to Kafka, in here, we are missing something. We do producer the flush, so the data can, of course, get delivered as expected. Yeah. And I think that's it. So let's run it one time. And before we run the full processing, in fact, I think the process should be good. So let's run it and see if everything is working as expected. Okay, so vehicle delivered to a message delivered to vehicle data, GPS, and traffic. Good. Weather and emergency data. Good. So the next time, I think everything should be getting delivered together. Good. So let's see how that looks like. If we list this again in our broker and the Docker desktop, you can see we have 5 topics that is producing data, and the data is inside them. So let's look at the vehicle information in here. So if I do Kafka console consumer and I get in the topic is this, and what I'm doing is to get the broker as well. Bootstrap server. The bootstrap server is broker 9092, and I want to start from the beginning. Okay, and yeah, let's see if that is good. And you can see the data is getting produced as expected. Lovely. So we are heading out to Birmingham. So we just wait for this to keep continuing until it gets to Birmingham, and maybe we just stop it. We delete everything again and we start from the scratch. So now, at this point, we have our data that is producing and the vehicle is moving on to Birmingham. So interestingly, we've not really handled the streaming part of the thing. It's just the production now. And if you look at our architecture on the in the system, you look at the architecture right now, all of this has been taken care of. We have our Kafka data set up now, but we haven't set up our streaming consumer that is listening to Kafka and writing to S3. That is exactly what we're going to be doing next in this video. Before we continue on to the consumer section, so let's configure our AWS because we're going to be needing that. So I just logged into my AWS account, and this is my console home. I have buckets that has been created called Spark Streaming Data, and I was thinking I would create a new bucket for that, but since I already have a bucket that is empty, so there's nothing new about that. So you can just create a unique bucket for you, and then you should be good. Now, one other thing that I want to mention is the permission for this bucket. So in the bucket, if you click on the permissions tab, the block all public access should be disabled. So when you are creating this bucket, it should be disabled. All right. Otherwise, you will not be able to access this from outside systems. Okay. And the bucket policy in this case is just for me to allow all get and puts. All right. So you can access the get request and put object into that. That's the only thing that I added to that. And this is the structure of that. If you want to see that, you can check this link in the description to get you to all of these codes and all that. Okay, so let's continue. So once this bucket is set up, and then you set up your bucket policy by clicking on the edit and maybe copy pasting this or typing it, anyone works fine. But once you have your policy and you you disable block or public access, the bucket will show publicly accessible. So that means it's easily accessible by anybody, and anybody can upload to that so far they know your credentials. All right. Now, once that is done, I also want to mention the user that I'm using is the admin user. So it has all the permissions that is required. So in my case, I have the administrator access, Amazon S3 full access, Glue console full access. These are the three access that I have right now, and that should be more than enough for me to work with. All right. So let's go back to our code and then continue. So because we're going to be needing all of this information by the time we get to the access and security credentials and all that. All right. So now in my code, we already have we already have a job in here. So what I'm going to do in this job is create a file that is going to be holding my AWS credentials. So I'm going to just touch jobs and then config.py. Now in this config.py is where I'm going to be having my AWS access. So I'll just go into the config and have configuration equals to this, and I have AWS access key, which is going to be in here. All right, that will be here. Then we have AWS secret key. All right, then the secret key will also be here. So I'll just in the background, don't forget, if you want to get the AWS access key and secret key, you have to go on to IAM for that particular user you're generating for. So just come to, or you click on this and then click on security credentials. Once you click on the security credentials, it takes you to the dashboard. Just click on the user and you see the users that you have access to. Now the IAM credentials in this case, you just have to come to the security credentials here. So if you want to click on the security credentials, I'll be deleting these security credentials because for some reason it has been exposed, even though you don't know the key, but it's fine. I'll delete it once it's done. So you have the access key in here, and because it's active right now. So if you want to add another access key, you click on create access key. And because your application is going to be running outside of AWS, you click on this application running outside of AWS. So I'll just click on next and give this temporary a tag, temporary key. All right, and then create access key. Then you have access to the access key in here. So if I copy this, I'll just use that as my access key. That will be removed once the video is done, so it's okay. I'll just copy this as well for the secret key. I'll just paste that and we should be good. Now with this created, I'll just close my config key, and in my Spark city that I created earlier, this is where we are going to be writing our Apache Spark script. Okay, so I I don't know if you can still recall that when we did our installation, we did pip. If you look at our requirement.txt, I think we already have it in here. We have PySpark 3.5. I'm still skeptical about 3.5. Let's proceed. If we have any issues with 3.5, we're going to downgrade this to maybe 3.3 and then we proceed. But for now, let's continue and let's see if everything is going to work fine or not. If not, we're going to downgrade the PySpark version. All right. So let's get in our SQL session from PySpark. From PySpark.sql, import Spark session. And we're going to be needing another thing like data frame, but let's stick to this for now. And then let's get our dev main. This is the entry point, which is the function that will be called. I'll pass this for now. And if name equals to main, all right, then we call the main function. So that means we're calling the main function from the entry point. Yeah, that means that sounds somehow. Yeah, that's what we're doing basically. So in the past, we have a Spark, which is going to be inheriting or getting data from Spark session. And we have Spark session.builder. So in our builder, we're going to have an app name. In this case, the app name is going to be smart city streaming. Okay, but before we do that, before we continue, I can recall that I mentioned to you that we are going to be fixing whatever issues we have with our master the other time. So we have 7077, which is where we are submitting jobs to. But if you click on this for 9090, this is our Spark master URL. Obviously, the Spark master has been running for some time now. Maybe it's just sleeping somewhere. We have 2 workers that have been created and assigned to this automatically. But you can add more workers like I mentioned. So for now, let's stick to that. And we're going to leave it at that for now. So going back to our code, I just wanted to show you that. So the port that we're accessing is 9090, not 7077, because 7077 is our Spark master URL where we are submitting our Spark jobs into. But 9090 is where the UI is, where you can see all the running jobs, the workers that are connected, and the activities that are going on your Spark cluster. So going back to the code, I just thought to mention that. All right. So once we have our Spark City streaming, we're going to have our config. The config is going to be the Spark jars. So for our streaming, we're going to be needing the Kafka jar, which you can get from Maven repository. Maven repository. I'll just click on that, and you can search in here for SQL Kafka. If you search for SQL Kafka, you see something like this, Spark SQL Kafka. And then if you come down, we're using the 3.5 version. So if you click on 3.5, you see the group ID in here. So you can copy the group ID. So I'll just copy the group ID in here. Okay, group ID to see. Yeah, let's finish this. Spark.jars.packages. All right. And then I'll just get this as a string. Then we have a full column to get in your Spark name, which is the artifact ID that you're working with. So this is the artifact ID. I'll copy that as well and paste it in there. Then we have another column for the version of the artifact ID. So this is 3.5.0. I'll copy that as well and get that in here. Good. So this is my Spark jar. I'll just minimize this for now. I have my Spark SQL. So that means my Spark can connect to Kafka with this jar file. Now, if you don't have this, you will not be able to access Spark with the jar. Okay, so that's one. The next thing that I want to add is the AWS. So there's a package that allows us to connect from Spark to AWS. So it's going to be the one that we're going to be working with in this case. So I'm going to have this typed, I think about 2 of them, but let's see if we can continue with that first. So we have, in this case, if you go to Maven repository again and type for Hadoop AWS and search for that, you will see Hadoop AWS in this case. If you click on Hadoop AWS and you click on the 3.31 version, I'm tempted to use the latest version, but I'll use this one that has been tested and working fine. Even though there are some vulnerabilities here, but you can just ignore them for now. I'll just copy this, this one. I'll just copy that. All right. Then the Hadoop AWS, which is this one, get that in. I get this in. All right. Then finally, I put another column for the version, which is 3.31. So like I said, I'm tempted to use the latest version, but we'll see how that goes. Maybe at the end of the day, we try to optimize this and see if you can use a newer version. All right. So those are the two packages. One other package that we're going to be needing is coming from AWS itself, AWS Java SDK. So let's see how that looks like in here, AWS Java SDK. So in here it's coming from AWS. So I'm going to be needing this as well. And I'm going to be selecting the 1.11, not the 1.12 version. That's a long one. So I'll just come down in here and search for 1.11.469. Yeah, this is the one that I'll be using. So we like I said, we can try to upgrade this for now, but I'll stick to this ones that have been tested. I don't want any surprises. All right, so I'll paste that and then get in my artifact ID, which is coming from this guy, AWS Java SDK. Copy that and then put it in here, another full column. Yep. And then finally the version, which is 1.11.469. All right, good. Yep, that should be good for us. And then let's configure our AWS configuration. So we have this set up now. The JAS has been set up. Then we have our config, which is the one that tells Hadoop and Spark how to connect to your S3 bucket. So we are going to have this as spark.hadoop.fs.s3a.implementation. Now the implementation is just the class that this is going to be calling by the time it wants to do that, which is org.apache.hadoop.fs.s3a.s3a file system. Good. And that's one. The next thing is the access key and the secret key, of course. So we get in the config. Then let's get in our config spark.hadoop.fs.s3a.access.key. Yeah, not GX key. Yep, good. Then we have the access key that is coming in is going to be coming in from config in here, right? So we have from config import configuration, isn't it? Then in our configuration here, we have configuration.get, and then we get in our AWS access key. I hope that is clear though. Yeah. All right. I hope you are following me though. Yeah. Let's duplicate this and then get this access. Instead of access key, we change this to secret key. All right. AWS secret key. Secret key. If I can only type secret key. Okay, finally, we get in our one final thing, which is the AWS credential provider, and that is the one that is going to help us use the main class that is going to be our provider in this case. So spark.hadoop.fs.s3a.aws.credentials.provider. All right, now let's get in that guy in. So it's here org. Not original, org.apache.hadoop.fs.s3a.implementation, then simple AWS credential provider, isn't it? Yeah. Now that's all we need to do, and that's all we have to provision in our case. So finally, we just press that and then get or create. Now this establishes a relationship with Hadoop and with Spark, with the JAS that we've just added to the system. Okay. Now let's proceed. Now let's use our Spark. So we adjust the log level. So let's quickly adjust the log level in this case. Even though this is optional, I'll just minimize this. The log level this is just to minimize the console output executors on executor really, to minimize the console output on executors. So you don't just print out everything in verbose mode. So Spark dot spark context. Okay, simple as that. Set log level, and we just set it to 1, and that's all. It's nothing too serious, really. Now let's get in our vehicle schema. If you can still recall, we have our vehicle schema in here, so I'll just put this on the side, and we go into our vehicle schema in here. How does it look like? Vehicle, weather, emergency, vehicle. No, not this one. Yeah, this is it. This is our vehicle schema. So I'll get in our vehicle schema from here. So we have vehicle schema. So the vehicle schema is going to be vehicle schema. It's going to be a struct type. So struct type. All right. And in this struct type, let's import that in from SQL types. So we have the struct field. Now let's import this as well from SQL.types as well. Spark.sql.types. We have the ID, which is going to be a string type because the UUID, of course. The nullable is going to be true by default. It's I think it's by default, just like that. So I have that ID. Then I'm going to just duplicate this a couple of times and just change the value in there. So we have the device ID, we have the timestamp, we have the location, we have the speed, we have the direction, we have the make, we have the model, and duplicate this a little bit more. We have the year, and we have the fuel type. Okay, and we don't need the last one in here. So for the device ID, it's going to be string. For timestamp, it's going to be timestamp type, isn't it? Yeah, let's bring that in as well. Location is going to be a string. Speed is going to be double. Yeah, let's leave that double type, isn't it? Yeah, then direction is string, make is string, model is string, the year is also going to be integer type. So let's bring that in as well, import that and import this as well, and we should be good with the structure for the schema for vehicle. So let's get in other structures as well. We get in GPS schema. Let's bring that in. Yeah, we have a GPS schema, and the GPS schema is going to be the same thing that we did in here. Just copy that, and we just look at the GPS. Where's the GPS? GPS data. So we have ID, device ID, timestamp. We remove the location. There's no location in here. We have the speed, we have the direction, we have the vehicle type. So let's get in that vehicle type, and that will be all for our GPS schema. Then I think we still have more. We have the traffic schema as well. Traffic schema. The traffic schema is going to be It's going to be struct type. Before that, I'll just look at that. Let's see. Traffic schema. We have ID, device ID. I'll just copy this. Really, everything in here. I'll just copy that and paste it in here. We have the ID, device ID, camera ID, timestamp, location. So let's get in that. So there's no speed. So let's this is camera ID, and that will be a string type as well. It's a string type. All right, timestamp is a timestamp type, and we have the location. So the location is going to be location. It's going to be a string type, timestamp, and a snapshot. Good, and that's our traffic schema. So final thing, maybe not final. We have the weather data. So we have weather schema. All right, weather schema, and this will be weather schema. It's going to be struct type. Of course, I'll just copy that as well. This is a little bit long, so I'll copy this one. All right, and in my weather schema, I'll paste it in here. We have ID, device ID, location, timestamp, temperature. Let's get that in, temperature, and I'll just minimize this a little bit. All right, I'll reduce that, maybe not minimize. Temperature, we have the weather condition. This is also going to be random, the choice, and the weather condition is a string. So we have weather condition. is a string. We have the precipitation. I'll just copy that. And it's a uniform, so it's going to be a double, so double type. And we have wind speed, all right, humidity, and air quality index. Good. And the rest is going to be humidity is going to be an integer. This is going to be a double because it's a random.uniform. And then we have this as well. Okay, good. And that's that for our weather schema. And finally, if you are interested, we can get in our emergency data as well. I'll just do emergency schema, and then it has ID device location, and I'll just copy this. I think it's about the same size. I'll copy that. Equals to emergency schema. It's going to be this. And we have ID, device ID, incident ID. So incident ID. We have the location and timestamp, which is good. And we're just getting our snapshot here. And snapshot is going to be type. It's going to be a string. Timestamp is going to come in next. Location, status, and description. So let's get those in. Status is going to be that, and the description is going to be this. And that will be all, really. I think it's just comma, and we should be good. Everything is fine now. Perfect. Now we have all our schemas. I just get this back into shape. All right. Now, once this is done, we need to read the data. So because there are multiple schemas in here, it doesn't make too much sense to keep duplicating the code every now and then. So what makes sense is to have a single function, or a single function that helps us with just passing parameters, so we can reuse that. One of the important thing about coding is DRY. Don't repeat yourself. So let's try to not repeat ourselves so much in here. Okay. So let's go back into our code and let's write that. So I'm going to have under emergency schema, we're going to have a vehicle data frame. This is going to be the data frame that is reading data from that. We're going to have a function called read Kafka topic, and we pass in the vehicle data, and then we have the vehicle schema, and we have the alias for that as vehicle read Kafka topic. So let's create this function. We don't have this function implemented. We can do that by just underneath here. We can just say def and get in our function here. So this is going to be the topic and the schema. And what we're going to be returning in this case is going to be the Spark, which is our Spark variable dot read stream, because we are reading from Kafka, really. So I'll just put this in here so we can have dot format. The format is going to be Kafka. And oh, by the way, if you are interested in this Kafka of a thing, there are a lot of videos on this channel that helps us to do that. Or you can visit datamasterinlab.com and you see more videos that you can watch and get more information about that. So we are subscribing to this, and this will be the topic. All right, the topic that we're bringing in. Of course, we can subscribe to multiple topics, but that's a discussion for another day. We have the starting off sets, and we're going to be starting at the earliest, of course. Yep, starting at the earliest. Then once that is done, we do a load. Now the loading is going to load the data for us, but what we want to do is just quickly chain the selection so we don't have to deal with the value, because by the time the data gets selected, you're going to have a column. So we just want to quickly fix that. So let's do the select expression for that. Select expression, one time we have cast, and then we have the value as a string. I'll put this as capital, and we don't need that. We're inside a bracket already, so we say select from JSON. Let's bring this in from JSON, and we're bringing in column. We're extracting data from the value column, and using this particular schema that we pass into that, and the alias of that is going to be data. Simple as that, really. Data. Okay. And finally, we have a selection from the data. So dot select, okay, select data dot asterisk. And then, yeah, let's bring in these guys. All right, let's bring in from JSON, which is good. Yep. And we get in our column from that as well. Good. Now, finally, once this is done, we want to set a watermark. Watermark is going to allow us to set the duration for delay. So just in case any of the data gets delayed within a specific window, we are able to get the data and the system still recognizes it. So that's the reason for our watermark. So in our case, we can set in 5 minutes, 1 minute, or as long as you are foreseeing a potential delay. So it shouldn't be too long and it shouldn't be too short as well. So let's leave it at maybe 5 minutes, or yeah, 5 minutes should be fine. So I'm just going to get in our watermark in this case. Yeah, I'll get in our watermark with watermark rather, and then the event column is going to be timestamp. And if you can recall, all of them have a timestamp, and that's why it is important to have a structure that relates to what you're working on. So in our case, we have a timestamp for all of them, and the delay threshold is 5 minutes. So maybe for this purpose of this video, I'll reduce it to 2 minutes for maximum delay. And that will be all really for our Read Kafka topic. And we do the same thing for a couple of videos as well, for the couple of schemas. So we do the GPS DF, and we just change this to, where is it? GPS data. That's the topic. We have traffic DF. And what else do we have? If you look at what we have in here, let's see all these topics. We have vehicle data. Yeah, we have traffic data. This is traffic data. We have weather data, and we have emergency data. Okay, just copy that. And in here we have emergency. This is weather DF, and this is emergency DF. Good. And let's change the alias. The alias in this case will be GPS. This will be traffic, and this will be weather, and this will be emergency. And this is important because we're joining multiple data frames together. So it is important we take note of that so we don't run into issues. All right. So let's join all of them. Join all the DFs with the IDs and maybe timestamp, really, and timestamp. Okay, good. All right, so let's start with that. So the very first one is going to be, let's have a joint DF. So interestingly, this may not be an issue because there are two ways we can actually approach this. We can join all of this and write the join data frame into S3, but that would defeat our purpose. But because what we want to do is have this in silo in AWS. So vehicle data frame, as it is coming in from our system, is going into a S3 bucket directly, and then we have the GPS, and if there's any transformation we want to do in the meantime, we do that as well. So instead of joining all of them in the Spark session, I have a rethink, and we're going to be pointing that to S3 directly. So instead of joining all of them, it is still possible, and I can still show you how to do that. Maybe for the first three data frame, I can do that. And you can, if you are interested, you can write all of that and write all of them into S3 as well. But let's proceed. Okay. So I'll just write this. I'll come back to this shortly, but let's see if everything is working fine first. And we're going to have, because we're going to be writing the vehicle, GPS, traffic, and all this information to S3, so it only makes sense to have a function that helps us to do that as well. So we don't have to keep repeating ourselves every time and writing the same code over and over again, just changing parameters. So let's have a stream writer in this case. I'm going to say stream writer. This is the one that is going to be writing data into S3. So we have input. The input in this case is going to be a data frame. And let's bring this in. Yep, import that from PySpark SQL data frame. Yep, that's it, isn't it? Yep, that's it. Then we have input. Then we have the checkpoint folder. This is where the the checkpoint is going to be. So in case of failure, you can recover from there and pick it up from there going forward. So we're going to be returning the inputs that we're writing. This is an input data frame. So it's going to be a write stream. In fact, I just put this on the scene, write stream. So we are writing stream in the format of Parquet. So we have a Parquet format, not Parquest. It's Parquet. Then the option in this case is our is dot format. The option we're working with is the checkpoint, which is the one we're working with. So we're going to have checkpoint location, and that will be our checkpoint folder. As simple as that. And if there's any option, we're going to have option for the output. So the path is going to be the location where the data is going to be sitting in. So we're going to have output as that. Then the output mode in this case is going to be append. Simple as that. So finally, we just do start and we should be good. Perfect. I don't want us to spend too much time on this. So that's our stream writer. Our stream writer in this case is writing Parquet to this to this path using this checkpoint, of course, and the output mode is going to be append. Perfect. Now let's make use of our code in here. So we're going to have a stream writer. Stream writer in this case is going to be vqdf. Then we have in our checkpoint folder, which is S3A, and I'm going to be calling that, if you can still recall, our Spark streaming folder is Spark streaming data, and I'll have this. Maybe I can rename that. I'll leave it at that. It's okay. And we have the checkpoints. We have vq data. In that case, once our checkpoint is secured, we have our output as well, where the data is going to be stored. That's the path where the data is going to be stored, really. So we have the S3A and the Spark streaming data / put this inside data, and I'll tell you why I do that. So vq data. So that's what we need to do in this case. I'll just duplicate this a couple of times, and we should be good afterwards. And I think it's about 5 of them, isn't it? Just put this 1, 2, 3, 4, 5. Yeah, this, enter, enter, and enter. Good. So let's fix this. So instead of vehicle data, we get in GPS DF in there, traffic DF into that, and weather DF into this, and emergency DF into that. So let's fix this. Instead of vehicle data, we have this as GPS data, and that will be the same thing here. For the traffic, we have traffic data. I'll copy that and replace this. Then the next one is weather data. We copy that and replace this. And then finally, we have emergency data and emergency. Now, interestingly, because we have multiple streams, how do we automatically write all of them into S3? Interestingly, before we do this, you just do writer just like you have it in this function. But the challenge with that is if you join multiple await query termination, you're going to have the first one only being acknowledged. The rest are going to they're not going to work, and you will think maybe something is broken in your code. So I'm going to show you a simple trick or a simple approach where you can write all of this at the same time in parallel to your S3 bucket. So let's quickly do that. Okay. Now, since we already have our stream writer in here, I'll just call this query 1, okay, and this will be query 2, and this will be query 3, and query 4. So we have 5 queries. Interesting. And query 4 and query 5. Good. So what we're doing in this case, if you can recall, we are doing a start, so it is not writing directly yet. So at the end of the day, the trick is just to get the last one, which is the query 5.await termination. So what that means is all of these that have been started will now run in parallel and in concurrently. All right. So let's do that and see if everything is working as expected. All right. So what I'm going to do basically is to now submit this job to our cluster, our Spark cluster. So I'll just clear this up. But before I do that, let's clear up our broker so we don't have anything left hanging or residual data from on our topic. Okay. So we have Kafka. Where is it? What's happening to our exec? Yeah, that's it. Okay, so I'll just clear this up. Yeah, maybe not applicable. So I'm going to have Kafka Kafka topics, and I'm going to be pass Kafka topics, yeah, delete. I'll pass delete to that. Then the topic that I want to delete, well, before I do that, let's list the topic so I can just easily recall the topic name. So yeah, and then I'm going to have, instead of topic, I'm going to have delete, and then the topic name is going to be GP emergency data. I'll get that in. Bootstrap server is the same, and I'll just keep changing that. Emergency data, we change this as well to GPS data. Okay, no way, that's GPS data. Okay, and then we have traffic data. Okay, traffic data, and I'll copy the vehicle data as well, so we can just delete all of that. Vehicle data, we have weather data as well, and finally weather data. So what we can do now is do a list again to see the topics that we created. So the rest are just internal topics. Good. So let's start by submitting this to our job cluster, and then what we can do basically is to execute into this Docker Compose and submit to that, because don't forget we are already doing a synchronization between our local jobs and into Spark jobs, so we should be good on that. In our Spark City, so we just do docker exec, and in here, this looks like a lot, but let's see. I'll clear this up and I'll say Spark docker exec, AT and smart city, and I'm submitting with all of this information. I'm submitting to smart city and Spark master, Spark submit, master the URL, and I'm passing the packages, all of these packages that I have in here. Interestingly, you see that I had this com.faster jackson.core. So what I'm going to do in this case is just remove that from there. Okay, I'll just remove faster jackson from here, and let's see how the system performs or behaves in that. So we have the jobs.spark city in this case. That's our jobs directory, and we should be good afterwards. All right, so let's submit this and see how that looks like on our cluster. So it's running this, and let's see on the UI what our cluster looks like. Local host 9090, and let's see that, and we have this. It's still not submitted yet, so let's see what's going on. So we just wait a few more seconds for the submission to be done. By the way, we've not started our main, so we need to start producing data. Otherwise, we're going to run into issues. So let's run this main.py. So these guys can start producing data into our topic. Otherwise, our Spark is going to say we couldn't find any topic like that. That was a nice catch, the nick of time. So I just list again. Do we have any data created here? Good, perfect. So now all our jars are getting downloaded, and let's see how that looks like. We just wait a few more seconds for that to be done. And still downloading. Yeah, it looks like it's the Java SDK, so it's going to take a short time for that to be done for the first time. But subsequently, we should be good. It shouldn't take this long the next time. Just load them from memory. Okay, so everything is working just fine, and I think it's loading all of them now. It's loading all of the jars, and the loading is done, and now the job is running. So let's see on the UI if the job is actually running as written on the terminal. Boom, you can see the application ID is running on 4 cores. The executor is here and is currently running. And if you click on the application ID, you should be able to see the details of that job. And these two workers are on there. So you can click on the STDR to see and follow the logs, but I will not do that. I can just follow it from here. So it says it's trying to cast values as string. There's an error in that case. And in our case, it shouldn't be, is this supposed to be values? Nope, it's supposed to be value. Where is it? Where can't I move this down? Oh, yeah. So that's a typo, really. Shouldn't be a problem to fix. Where are you? Show yourself. Show yourself. Values. Values. Not this one. I was looking in the, I was like, why can't I find this? Yeah, this is it. Values. It shouldn't be values, it should be value. All right. So I'll just resubmit that. So that failed, and it's bad. I'll just resubmit that again, and it's finding all of the jars. Okay. And good, everything is fine. So it just added all of the files again, and shouldn't take more time. Good. All right. So it's running. You can see now that the job is running. Another one. So this is completed now. If I do a refresh, we should be seeing the next one. All right. Smart City is currently running. No way. It's casting value as string. I didn't close the bracket. You probably saw that. No way. Okay, I'll submit that again. Oh my God. Yeah, that is getting submitted again. Let's see. Okay, running. Has this guy reached Birmingham yet? He's still traveling. Okay. It's a long way ahead anyways. And it says he couldn't find simple AWS client provider. And that's because of, is that an error in there? We have Ogdo Apache, Hadoop, FSS3A implementation, S3 client. There's no implementation there because it's a simple client provider. Shit. So I'll just remove that and submit again. So this is taking way too long to start streaming. I hope everything should be fine now and there are no typos anywhere anymore. Let's see how that looks like. I hope everything should be fine now. Try that do metric. Yeah, no issues. It's a warning. Our executor is currently running, so let's see how that looks like. Okay, I think everything is working just fine now. All we just have to do is wait a few more seconds. Once you start seeing a progress bar, that means the streaming has started, and we can now check our AWS for data. And right now, I think after this, we should be good. One more key deserializer or not. It's a warning, yeah, and we should be good. Yeah, that's the third one. I think it's about 5 of them. And I think it's writing them now. Maybe, let's see. That's the fourth one. Let's see what that looks like on our Spark streaming. This one, we just do a refresh in here, and boom, we have checkpoints. Beautiful. And our data, yeah, perfect. We have all of these 5 individual data, and the Spark metadata is written. That's the first one. I think it's about write ahead. This is about write ahead log. This is writing straight into our S3 first before every other data is coming in. So I think probably it could keep track of the data that is coming in, and maybe start again if there's any failure or something like that. So Yeah, you can read up about Spark metadata and all that. And I think all this should be done now, and we should start writing the data by now. All right, so we have weather data. Yeah, you can see the data is getting written, and that is a good, beautiful one. We're good to go now. Maybe not 100%, but at least data is getting written to, yeah, it's written to our AWS now. Traffic data as well. Perfect. I think the next thing is just to wait a little bit for the traveler to get to Birmingham. And I think we're using 5 seconds, aren't we? Maybe that would take a little while. But at least we know that this is working for sure, and we're streaming data live into S3. Good. All right, so let's see how that looks like. Now, while this is ongoing, the next thing is for us. We are streaming data into S3 directly as it is coming in from our IoT devices. It's going straight to our S3 lakehouse, which is good. So the next thing we want to do now is have a transformation. If you can look at the architecture we have, in the architecture we said once the data comes in here and we are streaming into S3 in here, we're going to use AWS Glue to crawl the data and create a data catalog for that. And we can now link Amazon S3 and Athena to that catalog. Okay, so let's quickly do that. I think that's about the last second to the last bus stop of our session, and the video is getting way too long now. So, but yeah, let's just continue. So let's go to AWS Glue. Now, AWS Glue in here, I have this is the console. You can see how the new console looks like. If you are interested in the old console, I think you can use the old legacy pages for connection and all this. We don't need them, but we just stick to this new one. All right. So what we're going to do basically is get a crawler that is going to help us do that. Now, before we proceed and run this query to end, I think we have a challenge, an error in here. So the GPS DF in here should be using the GPS schema, traffic as well, traffic schema, weather schema, and emergency schema. Okay, so that gives us the different schemas in here, and everything should be okay now. So the next thing we want to do basically is to structure this in the right way and run this. So I'm just going to trigger this up, Spark City, and then we run our main as well. So while this is running, no, this is running on my local system. It should be running on the cluster. So I'll just do docker exec smart city spark master and submit the job with these packages as well as that, and then this the submission file. All right, so if I submit this, let's see how that looks like. Takes a few seconds. Yeah, it's establishing that, and in our main, just adjust this to, let's say, 3 seconds, and then we run this again. All right, just run our main so the data can yeah, I think we should probably delete the data in here. So let's delete all of them in here. Emergency data, we delete GPS data as well. I think we should just stop all of this process that is currently running. Okay, I'll just stop that. Yeah, just stop that. Okay, and here I delete the emergency data, we delete the GPS data, then followed by traffic data, then vehicle data as well, vehicle data, and weather data. All right, so once that is done, the next thing is for us to now start producing and start and resubmit our scripts again. So I'll just resubmit this and then start our main on the side as well. Okay, and let's run this so you can start producing. So you can list the data in here again to see if the topics have been created, and we should see that they have been created. Right now we have the 5 topics in here, and they should be getting produced to Kafka, to our S3. So we just do a refresh in here, and it takes a few seconds for that to be done, and we should start seeing data in a few seconds. All right, so this is currently running. and that's a good thing. And you can see that on the UI if you want to follow through. All right, I think this is getting written to AWS right now. Since I think when you can see this, I think you should probably do a refresh on S3 and you should start seeing data in there. All right, at least the structure should be laid out right now. And you can see the checkpoint is here now. We have data. Good. And inside the data, we are going to start seeing records dropping in a few seconds. And the GPS data is currently here, but do we have any data written already? Not yet. We only have the right ahead, the Spark metadata written in there. Not a bad thing, really. Just wait a few more seconds for that to be done, and it's still running. Okay, so the driver is still heading to Birmingham. So we just wait a few more seconds for this as well to continue while we also continue on the side. Okay, so data, do we have any data now? Yeah, all of the data have been represented correctly here. So let's look at the vehicle. Yeah, still loading. Okay, and here, what do we have? Okay, I think we should do a refresh now. Yeah, data is getting written right now, and it's a good thing. Let's see if the driver has reached Birmingham yet. It's still going there. Good. So it's still on the way. So that means the data is written in real time to AWS, which is good. And let's continue. I think it's because of the delay in here that is reducing the number of minutes, but based on the delay threshold. Yeah. So, but that's on the way. While this is going on, we go to our crawlers and we can start creating our crawlers. I think I can just do a refresh in here. We don't have any. Yeah, I think we do. I just delete all of this. Instead of creating separate crawlers, we can use a single crawler to do that. Just delete that. And that was the whole crawler that I have. So you can create a new crawler and link it to your S3 bucket. So we can say Smart City Data Crawler. Okay. Just like if you select that, you can use any name. So I'll just select Browse here, Spark Streaming, and then in my data, I'll select data in this case. So because I want to have access to all of the data in the sub directory, which is the subfolders. Then interestingly, because of the Spark master, Spark metadata, this one, we need to exclude this from being crawled by this guy. So we just come in here, get in our Spark metadata. I'll just try a couple of methods so it won't crawl the content of Spark metadata as well. And if you are getting in there and getting into Spark metadata, you don't crawl that. And anything that looks like metadata, Spark underscore metadata, you don't crawl it as well. Good. So I'll just leave this as the different pattern that it can be matched. So I just add S3 source in there. Next, then IAM role, I'll be selecting smart city. It's just as simple as creating a new IAM role and giving it a name. If you don't have it before, just click on create a new IAM role, but I already have one, so I'll use that. Then next, then the output, where is the output? I'm using smart city as my database. If you don't have it, you can just create a new database by clicking on add database and give it a name. That's all. And in the advanced options in here, it says create a single schema for it. I think I'll just leave it at that and just click on next. If there's any other thing, we can always recrawl much later. But for now, I think our crawler has been created and the driver should have reached Birmingham by now. Shouldn't take too long. Our vehicle has reached Birmingham. Good. And now we can run our crawler. All right. So it takes a few seconds for the crawler to be done, about a minute or thereabout. But let's see what the output looks like if we are going to change the content of our crawler or not. All right. So the crawler is done. It's done running. It takes 1 minute 15 seconds. And let's see what the table it creates. And interestingly, it creates them as we expected. So these are the 5 tables that have been created. Are they? Yeah. So they are the 5 tables that have been created and everything is working just fine as expected. So 2 ways by which we can proceed now. We can actually select the view data from here and it directs us to Athena, or you can search, with the search bar and type in Athena in there. You have access to Athena. So let's explore the 2 routes. So if you click on this and click on proceed, just view data, table data in this case, you have access to the Athena editor, or you just click on here, just search in here, search for Athena, and you can, open this in a new tab as well. So you have both actually give you access to Athena. So interestingly, if this is the first time you're accessing Athena on your records in here, in your system, you will see something like this. So you might see something like set the output. So you can come to the settings in here and change the output in this case. So the output of my query location has been set as this. So if this is the first time, you'll see something like this and you can actually set the output where you want the output to be. So I just set that to my output location in there for the query editor. So I just link that to my S3. But as simple as just running this, we can just run this and see what the output looks like. So we have the device ID, incident ID, and these are all the emergencies. So there's an accident, police. This is somehow because a lot of accidents happen, medical information. But this is just like a representation of what is going on actually. Now, the next thing is going to be for us to, maybe visualize the rest of this data that we have in here. So we have emergency data, we have GPS data as well. Let's see how that looks like here. This is how the GPS information looks like, which is all of this information, and you can see the speed, direction, and all that. Good. And what else do we have? We have traffic. Let's see. This is the traffic, and this is the location that it happened. We have vehicle data. We have this. Good. And you can see the information that was sent across. And then finally, we have the weather data. Okay, weather data. And if you run this, this is how it looks like. So easily we can download results, copy that anyhow you want to do it, and it's as simple as that. Now, let's head on to Redshift now and start creating our cluster if we don't have one before, but if you have one, you can also use that one as well. So let's create a new one. So I'll come in here and type in Redshift. Okay, Redshift, Amazon Redshift. So I already created a cluster, but I can create a new one. It takes about 15 minutes for the cluster to be done, the cluster creation to be done. So what I'm going to do is create a new cluster here. Then I'll call this smart city cluster. And then I'm not going to be using the 4 times extra large. I'll be using the large. And I'll be using a single node because I'm not doing anything too crazy. So it's about $182 per month. And the username is going to be AWS user. I'll delete that once we are done. And then I can just add a new admin user in here. So the password for the admin user has been added to that. And then we can associate IAM role to this. So I have a Redshift role that I created. So, but if you don't have this, you can actually create a new role in here by clicking on this, and it takes you to IAM roles. I think you can come in here and come to IAM roles. So if you come in here and click on roles, you see the roles that have been created. So right now, these are the roles that have been created. And if you click on any of that, so let's say I create a new role, AWS service, all right? And the use case is going to be Redshift. Okay, I click on that. Then the Redshift customizable, of course. And I click on next. Then I can now select any activity that I want in here. So what I want is the S3 access. So I want S3 read-only access, S3 read-only access. I don't need to write anything to S3. I just want to read. So once that is done, this is the trust policy that's applied to that, and this is the permission. And once that is done, I click on create role, and let's give this a node: smart city Redshift S3 role. Okay, and I just create role. All right, now I have smart city Redshift S3 role. Here I can come back in here and associate IAM role to that, and smart city. I think we should be able to do a refresh in this case, shouldn't we? So what can I do to do a refresh here? It's not added to this list, so I can just do a reload of this page. All right, I'll just do a reload. All right, so I have smart city Redshift cluster. In fact, I'll just call this Redshift cluster. Okay, cluster. Then I'll use the large and a single node. And by the way, you can use a trial version of Redshift, so you should be good if you use the trial. So I use SQ AWS user, associate IAM role, smart city Redshift, and I associate that to that. Then additional configurations. I don't want to use the defaults, so I'll select, I'll uncheck that. And in my network and security, you'll see that there's a publicly accessible in here. I'll allow this to be done, and there's no elastic IP address that I'm associating to that. If you want to add any elastic IP address, you can do that. Then in the database configuration, everything is going to be left as it is, and every other thing will be as they are by default. So I just create the cluster, and then this is going on in the background. So I have a smart city test, which is undergoing the same process as this one. So I'll just wait for this to be done. In fact, I will delete this one. I don't need it anymore. I'll just delete this cluster and type in delete, delete cluster. And while this is going on, we just do a quick pause and play for this to be done, and then we load that into our Redshift. All right. Perfect. So the Redshift cluster is done. If I do a refresh now, it should be available. Good. So if I click on Smart Shift Redshift cluster, I'll be able to see the connection credentials and now how to connect to that. Excuse me. Now I have the endpoint, I have the JDBC, and I have the ODBC URL. So I'll be copying the JDBC, and that's what I'll be using to connect to that. So if you go to so if you go to DBeaver in here, DBeaver is my IDE, but you can use any other IDE that you like. You should be able to access all of this information in here. And if you click on the plus sign to add a new connection here, you search for Redshift, right? If you search for Redshift here and you click on next, then you can use the URL to connect to Redshift. In this case, you just paste in the URL that you copied earlier. Once that is done, you have access to all of this. Then in the database native section, your username, which is here, the one that we use actually to when we were creating. I think we should see that in the properties, shouldn't we? Yeah, I think so. It's not here. Is there anything that I need to check here? I just want to get the user. I think it's AWS user, actually. Database configurations. Is that not? Yeah, I know for sure it's AWS user, but I just want to see, yeah, edit admin credentials. And the admin, this is admin password. And do we have any other thing in here? Yeah, AWS user. I was looking for this. AWS user is the username. Okay, the password that I copied or that I typed in earlier, I just need to do a test connection in this case. So if you don't have the driver, DBeaver automatically downloads the driver for you and you can use it to connect. Now, once that is done, I click on the dev and you should see the databases that is currently available. The dev is the one that I just have access to right now. And you can see the schema in this case. We have public, and in public, you have access to this table, nothing, and nothing is in here. So for us to have access to this and for us to be able to query this, we already have our data in AWS catalog, in our Glue catalog, really, in the data catalog of Glue. So what we can do now is load the existing data catalog that has been loaded into Glue into our Redshift. So we don't have to connect to the AWS. We don't have to connect to separate S3 buckets and start loading data from there. We don't have to do that anymore. The data have been crawled and loaded into Glue. All we just have to do is connect to that. So let's do that by creating an external schema. We can just right click on this, open SQL script. And in here you have dev and public at dev. So I'm running this against the public schema. So it's fine because I'm creating a new schema. It's fine. So I just do create external schema. It's better you had external because it's not into Redshift. It's not inside Redshift. So I'll call this the schema name that I want to give to this. I'll say smart city. All right. Then once I have the name in here, where do I want to load from? I want to load from data catalog. In this case, data catalog. I'll type in data catalog. Okay. Now, where is the data sitting? What's the name of the database? Okay. Database name is called, what's the name of the database name? Smart City. Smart City. I'll say, let's say dev smart city is the schema and the database name is schema in this case. Now we need an IAM role. If you can recall, we associated an IAM role when we were establishing this, which is the smart city Redshift. If I click on that, I have access to the ARN for the IAM role. So if you copy this ARN, I think it's a AWS role name or something like that. You can copy that and paste it in here. So I have the IAM role as this. Then which region am I working on? I think it's the US East 1. US East 1. And if you look at, you can double check that to see if you are actually right. I'm right or not. And I think this should be, where is it? US. It's not, yeah, US East 1. You can see I have US East 1 here, even though this is the namespace, but there's a particular place where the US East 1 is sitting. This one, availability zone. This is it. This is my region. I'm not using the F, but I'll just leave it as 1. Okay. Once that is done, I had a semicolon to that, and I highlight all of this and run. You can see that this created successfully, and the updated rows is 0 or something like that. It's not updating anything. So for you to see how this reflects, you can come in here and do a refresh, and here as in the database and do a refresh. It takes a few seconds for the schema to show, and once it is shown, you double click it and you can see the details of the data in here. You have tables, so the tables should show in here, but for some reasons it is not showing. Let's see if we can query this. I'll just try to query this directly. I'll comment this out for now. I'll say select star from dev smart city. I know there's vehicle data in here. So I have inside here, what schema do we have? Yeah, that's the schema name, rather. So I have the GPS data. All right, so let's see if we're able to select data from there. So it says access deny exception. This person doesn't have glue get table. So let's fix that. In our IAM role, which is this one that we created and added here. Is it not this one? I have only read-only access to Smart City. This is for S3 alone. So let's add a new permission and attach a policy for Glue as well. So Glue console full access. Excuse me. And yeah, I will use that and add permission to that. And we should be able to access this now. Hopefully, let's see. Okay, I think it's querying and perfect. So we have been able to access this. And if you look at the Dev Smart City again and you do a refresh here, can you do a refresh here? Refresh, yeah. If you do a refresh, you can see all of this information being populated. So you can see each of these guys and the location where they are, all right, in the S3 bucket, and the input and output format for each of these data actually is here, the table space, row count, even though the row count is not here, but you understand the data is still pretty much inside there. And you can double click on this to see the data, actually to see the content of the data. But this is a read-only access, so it's fine. You can just do a read-only in here and you can see that. Good. Okay, so that's how to query this. If you want to now write your complex script against all of this data, you can do that, and it's easy for you to proceed from here going forward. So easily we can connect our Power BI or visualization to like Tableau or Looker Studio to this Redshift, and we can easily just dimension and maybe query this as we like. All right, so but that will be on request. So if you would like to see that done in Power BI or Looker or Tableau, let me know and I'll create an addendum to this video where we have visualization for Power BI, Tableau, or Looker as requested. So thank you very much for watching. But if you have not subscribed to this channel at this point, please don't forget to like, comment, share, and subscribe, because this is how I'm able to support this channel and how this channel is able to create videos for free. So if you would like me to continue for free, don't forget to like and subscribe, and don't forget to share the message. And thank you very much for watching. I'll see you in the next video. Bye.